All right. So please enroll for the week 3. So you can even enroll in home like when after Wednesdays, every Wednesdays it will be open. So you can enroll for in home and you can go through the course material. But we will discuss those things every week here. So you'll be able to self-enroll. Huh? Yeah. Just go to week 3. Yeah, you already in. Already. Yeah, you are inside. Yeah. So you can do that from home itself after every Wednesday. All right. So we will give the access. So during last week, we were discussing about the Python programming principles. So why we need a programming language, right? So basically, if a person need to, if I want to communicate with a Chinese person, I don't know Chinese, right? So there is a person who need to interpret what I talk to the Chinese person, then only he can understand, right? When he talk back to me, there is another person need to be there who can translate the Chinese into English or the language that I can understand, then I will understand. So the same thing is happening in the program. So if you take Python, Java, many other languages, C Sharp, C plus, and JavaScript, every language, whatever you take, finally, all the languages are made in such a way to communicate with the hardware in the computer, right? So the what is the difference between the program to program? Only the scripts. So the way you type, right? So the way the translator communicates to the computer. So compiler. For example, I can say, "Hi, good morning," in like in singular, I go. So the translator can translate it in the English. So he can say, "He is greeting," one way of translation. So the other person is an English guy. I'm talking in singular. Then he need to translate from singular to English mean. He can say, so he's trying to say good morning in singular. Second way. So there are different way he can translate, but the same meaning, right? The same meaning the English person is going to understand. I'm greeting him, right? Or him. So now the issue is the compiler. So that is the guy connect our language, what we type here, to the hardware setup. So when we code in different language have different interpreters. So it interpret in such a way to the hardware. So if you take Python is a really heavy language when it's come to hardware. Because I say I go on, he can say good morning. Instead of saying good morning, the Python say he's trying to say good morning and welcoming you, something like. So the hardware get little bit loaded, right? But Python is good in such a way because it has little faster libraries and compiler is faster compared to other programming languages, and it has a lot of libraries for many other purposes, right? So later on, the many other software like JavaScript, Node.js, React, there are a lot of things came up because they are specified in certain purposes. Python is a general language you can use for AI, front end, all the development purposes. C Sharp also the same. But if you get JavaScript, Node.js, other programming languages, those are specified for a certain purpose. So they are fast in that fact, and that has a lot of libraries. So we don't want to go into that languages. So we are going to go in Python. The main reason we have a lot of libraries which is specially built for AI applications. So that's the reason we are going to use this Python. So during last lectures, if anyone didn't join during the last class, you can go to the week 2 and there is a video, avatar video, as well as the, you may not have the access to avatar video, but the last lecture video is there. So you can go through that one by one and execute and understand what we have learned. So those are very basic stuff. So how to code in Python. So we have three variables, basically string, integer, float, and there is one more that is used for Boolean, right? So true or false. So these are the four variables that we are going to use in Python most of the time. And also we came across how type of storages, right? Tuples, dictionaries, those kind of stuff. So how to store certain elements inside the computer or inside the Python environment and call it back when we want. And also we came to if loop and for loop and while loop. So these are the things that we have learned in the first lectures. So those things we will use when it's come to the Python programming in the upcoming weeks. So today we are going to move a little bit more into detail in Python programming. that is file handling for AI. If you click that, you will get route to that place, file handling for AI. So if you put it to 125, you will get a better view. Yeah. So the first one is creating a text file, right? So why we need to create a file? We can store these elements into the Python environment while we are working on, right? As a tuple, dictionaries, and many other ways we can store it. So why we need to create a text file and store the information? So when we are running the program, when we connect to these kernels and when we are running the program, most of the storage elements are stored temporarily. While running the program, it will be stored. So when you reset and connect to a new kernel, you cannot get those data and run it. So you have to run from the beginning all these programs, right? So now the issue is, what if I'm going to run a program, I'm going to store some data, later on I need to retrieve and use that specially. So then you need to store these information in files. So we have three file formats most commonly used in AI programming. One is text file. So most of the data we can put as a text input. And the second file is CSV, Excel file, right? Mostly Excel file or CSV. Third one is the JSON file, right? So we are going to learn all these three type of files, how we can create, how we can execute, and how we can store information, get the information from the file, read it, close it, all those things we are going to learn. So I'll show some example programs before I go here. Say here you can see certain information. This is a JSON, right? So the JSON file is this one. So mostly I will run this example once we at the end of the lectures, and you will get to know why and where we can use this information. Okay. So first we will learn how to create a text file. So as a summary, you know how to run this code now, right? So you can go click this part, go to play and play it out, or go to this box, shift enter, right? If you click shift enter, then it will execute the environment. So now we will move into the text file creation. So when it's come to text file .txt, so where we save textual data. So basically, when it's come to converting speech to text and storing those speech to text element into a file, then get it back and visualizing all these things done in text to saved in text file. For example, here also we are talking, right? And it's understand, store it in the text file, then send it to the AI, then the AI understand and send back. So the chatbot here. So we have done it in that way only. Okay. So now let's create the text file. Okay. So to run this, file one is the code, open my file text. So I'm going to save it as login, right? You can edit it also, right? My name, you can create on your name, logi doc text, comma, W, right? This W is put over here to open the text file in the writing mode, right? Open the text file in the writing mode, right? So I'm going to create a text file. So once I execute this one, so you can go back and see here. So there will be a text file called logi is opened, right? You can also change your name and you can write out. Logi.txt is open, right? So let's open and see the logi text file. Nothing is here inside. It's just a blank .txt file.
Dr. Logi, I cannot hear you. Dr. Logi, can you check the sounds? Dr. Logi, can you hear me? I cannot hear you. Dr. Logi, I cannot hear. Dr. Logi. I'll have a call. Dr. Logi, Chetana. Dr. Logi, no sounds.
Excuse?
Minami, there is an issue with this. I think Dr. Logi has logged out from the session. I told him to get logged in again.
Okay. Okay.
All right. So now we opened a file, wrote something. So how we can read something from the text file? So to do that, first we have to open the file again because we created the file here, text file. In the writing mode, we have written something inside it and we closed it, right? We have closed it now. So now we have to open it back to read it. To do that, I'm going to say file, open, my file doc text. So here I need to put logi because I have changed the thing over here, right? Logi text. So I need to change it to logi text. And this R means reading only. You can write in the R format. So the text file is going to get open in the read format, right? So now I'm going to say, okay, file one, I'm opening the text file into the Python environment in the reading format and read content file one dot read, right? So then I'm printing, we know how to print. During the last lectures, we have seen couple of printing options. So this read content, I am printing it. After printing it, I am closing the file. So I am opening the file in the read format. I am reading the file and I am printing what I have read and I am closing the file, right? So once you execute this, you can see whatever I have written over there is printed over here. Whoever leads the AI race will lead the future. Welcome to the week 3 of AII Club program. Right? So now, first we created the file, written something, and now read something from the environment. Okay. So now, again, I need to change this because I have created Logi. Okay. So then, if you see in all these previous things, I have used this command file1 dot close. Here also file1 dot close. Right? Every time I am putting file1 dot close because I am opening it, writing option, writing something, close it. Opening it something in reading option, reading something, close it. But it's obvious we don't want to close every time, right? So this command need to be executed all the time. So to avoid that, if you use this with open, rather than just say file open, just open, if you use with open, it will automatically close. That means if you open the file, if you do whatever you want to do, after that the file get automatically closed. You don't want to go and type this file dot close option. Okay. So this with option, with open option is that one. So now again what I am going to do is I am going to file print, enter. Whoever leads the AI race will lead the future. Now we didn't put the file close option. It's an extra line of execution. What happens in Python is a line by line interpreter. So when you run the Python code one by one, it's going to go and execute what we are saying. If you add one extra line in the Python, it's going to execute this line also. It's going to slow down the process, right? It might be in microseconds, very fast. But if you have file close, file close, file close, thousands of file close, you will feel a second delay, right? So we don't want to happen in that manner because everyone want the results in real time. So I was working in example, I'll show at the end. So when I demo it to the client, they said 30 seconds delay to the results. They said 30 seconds is too much. We need it in real time. So what the problem is, you can't do it in real time. So there will be couple of seconds delay. When it's come to AI, the delay is obvious because it's a large model that we are going to build up, right? So with that, if you add extra unnecessary lines of code into the Python, it's going to delay the output. So we don't want that. So we eliminated that file close option by using this with open command. Okay. So with open command means it automatically closes. So earlier, the same code we ran in 4 lines. Here we are running in 3 lines. So that means we eliminated 1 line of code, which is going to be faster when it's processed. Right? Clear? Why we are doing this? Okay. Good. So now we have done it. We open the file with open option. That means it's going to close automatically. Then I read using the file read and printed the same thing. The same code is above, only this one is not there. Okay. All right. So now I have written something using this file write. Right. This is the first time I use. But now I need to add something into that text file. So last time, when we are saving something into an existing tuple or its existing dictionary, what we have done? We have appended it, right? We have used an option called append to the file. So that is the same thing that we are going to do over here, this A option, append. So writing W, reading R, appending is A. Appending means I'm going to append. Today we are going to learn about the file handling in Python. This one, right? Into the text file that I have created. So I have this one. I need to change my name because I changed it over here. So I'm going to go there, shift, enter. Now this line should be appended into the text file that I have created. So if I go back, go over here, open up Logitext. Here you can see today we are going to learn about the file handling in Python. Clear? It's appended into the text file. So if you remember, I told you this part, this slash n is used to go to the next line, right? So let's append something new. Here, I'm going to type something and I'm going to append another new thing. Maybe say, hi, how are you? Just for seeing that, because in the previous one, I didn't put the slash n, just the dot if you see. Now, if I execute this one, right? So it is appending hi, how are you? But you can go there and open in the file format over here. You can see this. Need to close it. I need to open it back. Yeah. See this hi, how are you? Continuous way, right? So now I know how to append, how to create a file, how to write something inside it, how to open it and read it something, and how to close it, and how to open it, read it with the with open option, which will automatically close. And we can see now again by writing that code. Sorry, this should be Logi again. Right. Whoever leads AI race will lead the future. Welcome to the week 3 of AI Club program. Today we are going to learn about the file handling in Python. And just I have added to show you, hi, how are you? It's continuously writing, not in the next line. So the next line, if you want to append it, you should go here and put the slash n option, right? If you don't put that slash n option, it's going to continuously write. Clear? Okay. All right. So there is a practice example that you have to do. Build a Python program that saves the following AI speech to text converted text into the text file titled myspeech.txt. Make sure the sentence is saved in new line. Also make sure the same thing. You can go back, look at the codes, and you can rebuild. If you have any doubts, go to our AI teaching robot, select the week. We are in week 3, and you can ask any doubts to the AI teaching robot. It will be able to answer all the stuff. Okay. Right. So now we have successfully learned how to create a text file, how to write something into the text file, how to read it, and how to append it. This is all we need, right? So back to back, these are the operations that we are going to do. So now we have learned the text file. The most common file that we have used in the programming language to save data is text file until the JSON file come into action, right? So why the JSON file is so important? JSON file is little faster when it comes to execution, right? So text file do the job perfectly. But when it comes to hardware execution, hardware finds it's little hard to execute the text file. So it takes couple of more steps. That means it's going to slow down the process, right? We cannot see it in real time. But when you are dealing with multiple text file, you have to wait until it's load and read and do that stuff. So to overcome that issue, they came up with the JSON file. Now we are going to learn about the JSON file. Clear why we are going to the JSON file? It's a faster and easy, and most of the people right now, whoever works in Python, they are saving all the information in JSON. Even we do that. I will show what this program is. This is the structure of the JSON file. It's very structured, line by line. It's, have you seen something like that? Yeah, right? Dictionary last week. It's stored inside the brackets and everything. So it's easy access. So mostly the dictionaries are stored in this thing. So now we will come to the Python file. So let's see there in Python, sorry, JSON file, right? So now if you go here, so where we actually store these information in a JSON file? In a practical example, so the recommendation system, when you are using these example for a, like if you are looking at Netflix film, so when you go next time, the Netflix film say you recommended, highly recommended. So how they do it? because based on your taste, the way which genre of movies that you are watching, an AI model says you this might be suitable for you, highly recommended, because based on your genre that you watch continuously. So while you watch, all these informations are stored as a JSON file. Then the AI take the JSON file, AI check the JSON file and see, okay, this is this genre. Okay, these are the movies that you should watch. And when it's come to Amazon, maybe Daraz, I'm not sure whether they have this option or not. In Amazon, they have this. When you buy certain stuff, let's say you buy an iPhone, when you buy an iPhone charger and the headset, when you're about to check out, it will recommend something for you to buy this back cover, buy this thing, because when you add everything to the cart, right, as I said last time, the same example, all these things are added into the dictionary form, right? Add to cart, add to cart, add to cart. So all these things saved, all these things in the dictionary format in a JSON file. Before checkout, the AI model quickly take the JSON file and run it and see, okay, he have bought iPhone related stuff. Let me recommend these iPhone related stuff for him to buy, right? So then the recommendation systems comes in and you see, yeah, it might be cheaper to buy this also, because they come up, the people who bought these before bought these also, right? If you used Amazon, right? So then you buy it automatically. So all these things are saved in JSON file. Before you click checkout, the JSON file goes to the AI model. AI model check the JSON file. Okay, this guy bought an iPhone, a charger, and something. Let him recommend this stuff. Then you see it in the visual display, right? So how to store this information in the JSON file is very important when it's come to AI applications or any applications, right? Okay, that's recommendation example I took here. So let's go and see how we are going to create the JSON file. The same way, no command change. Only thing that you have to put is import JSON, right? So import means actually, I told there are a lot of libraries built up in Python, right? So these libraries, when we are working with certain file formats or anything, we have to import them into our program. So importing, right? So to import any libraries, we use this import command, right? This import command you will see hereafter frequently in AI program, because AI program that we are going to use completely libraries, right? So you are going to install the libraries and you are going to import it to the Python environment, right? So here we are going to work the JSON file. To handle the JSON file in Python, they have installed a library, which is JSON. So I am importing that JSON library into my Python environment, right? Now the Python environment is set to handle the Python JSON files. So after that, the same command, if you see here, instead of doc test, right, dot txt earlier in the previous example, I just dot json, right? So once you enter, I'm going to change this one to Logi, maybe, and shift enter, right? I imported the JSON. I created the JSON file now. Okay, so let's go and see the JSON file open here. This is the JSON file, right? Logi.json is opened over here. Let's open it and see. This is how the JSON file looks. Root, there is nothing inside because I didn't write anything. Yeah. When you are working with Python programming, JSON is the best to go for because it's fast. Text file, yeah, text file is good for us to understand. For the computer to understand, JSON is the best. Yeah, and it's faster. It's faster in processing. Right. No, JSON is a file format. Yeah. Even Java, people can use JSON file or C++. Any program language can use. No. Right. So now, let's say the same example that we took. A person go to a Amazon web store. He is purchasing certain item. Then now we are going to see how these items are saved in a JSON file before he check out for the recommendation system. Still, we don't know how to build a recommendation system. That comes to AI, right? We will take this example again over there for the recommendation system in certain places. So now we will see when this guy add this thing, add to cart, add to cart, add to cart, then how the JSON file get appeared, right? So now what we will do is we will create the data. So the data is customers, right? The customer's name is Michael. The Michael is purchasing. This is not new to you because this is the same dictionary format that we have learned last class, right? So the purchases, and if you see iPhone 14, iPhone 14 back cover and iPhone 14 screen protector. So these are the stuff we buying, and I'm closing it into this bracket. So this is the data, right? So now I'm going to write this data into the JSON file that I have created. So the JSON file that I have created is logi.json. We know we are going to write this part data into the JSON file. So that means I need to open the JSON file. Here I am using with open option. If I am using with open option, we don't want to add additional command file.close, right? So hereafter we will use with open because we don't want to load the Python and the computer. So with open logi.json in the writing format W as a file, and I'm going to JSON dump. In text file, we used file.write to the writing option. Here I am using JSON.dumping, dumping the content into the JSON file, right? So not write. JSON.dump data, comma, file. All right. Once you execute this one, now it's dumped these data file content into the JSON file. You can go here, open up the JSON file. You can see root and the customer's big library. When I open this big library, there is the first name, because we know in the Python, we don't count from 1. 0, 1, 2, 3, right? So the first data that I'm going to happen is going to count as 0%, 0, 1. So in the 0th person, the name is Michael. And what are the things that he has purchased is iPhone 14, iPhone 14 back cover, and the third is iPhone 14 screen protector. So now it's in a very systematic way. Now it's written. So now when you are working with JSON file, text file, the problem is this is going to stay as a text, plain text. So when a person need to get something from the text file, let's say 1,000 customers are there. So if I want to find the text file, some name, so it need to go by one and find those things. But here it's very easy because it's saved in a systematic way. So when you search, it goes only the 0%, go to that certain point. In text, we can't do that. So that's why the JSON is very fast. So this is how now it got stored, right? So we will go back. We have dumped the data now into the thing. So now let's see how to read the JSON file back into the Python environment. So to read it, we use with open. We are opening it. And again, this is should be changed to my name because I created the JSON file as logi. So logi.json, read, right? Read. So here, R option, the same thing, the way we did it for the text as a file, data, JSON, load, right? There dot read, here dot load file and printing the data. So now it's done. You can see the customer's name, Michael, purchases, and all these things are printed out. So I open the file with open because I don't want to add the last line, file close, and logi.json to R as a file, data, json.file, print data, right? So now I loaded the file, got the data printed over here. Why it's like this? It's brackets, see, all are brackets. See, this is a dictionary format, right? All right. Question? Okay. All right. So now, this is one guy, Michael. So there are other people coming in. So I need to store all these people detail into JSON file, right? Because when this guy come back to the Amazon environment again, I need to see, okay, this guy came last time, he bought iPhone related stuff. Let me recommend some other iPhone related stuff he might be interested in, right? So these are business tricks, right? The people, we don't want it actually, but by recommending plus 10% offer, then we tend to buy those stuff. So that's these marketing companies do it, right? So now I'm going to add a new customer. Okay, these are the new customers. I'm opening it, the data file in the thing. The first customer inside the curly bracket, the second customer, right? Name Jennifer. She has purchased Samsung Galaxy S3, Samsung Galaxy back cover, and everything. And the second name I'm going to append is name Johnson, purchases Moto G back cover, and Moto G charger. So these are the new customer data I'm going to append or write into the stuff. So here again, data, customers, inside the customers, okay, I am appending new customers. Appending new customers. The new customers is are the one that I have created, right? So here you can see I am dumping that into the customers, right? So if you go back to the data, I am putting them into this file, customers, right? So here I am data dot append. Append is the fun when we are rewrite it again, right? Writing is first time. Once the file is written, after that, whatever you are going to put into the file is going to be appending option. So I'm going to append the new customers. New customers are these ones that we have created as a dictionary. So now what I'm going to do, I'm going to open this one, test JSON, W, and as file. That means it's open the JSON file, JSON dump the data. This is the one data, comma file. So once I execute this file, so now the JSON file is updated, right? So I have appended the data. It is little different than the text because text we directly appended it. Here we are opening append option here and calling that for the dumping option here, right? A little different way. So now if I go there, you can see the customers library, go here 0. Now, a second, I need to open it back again. Yeah. So customers 0, purchases Michael, it's not appended. It's in the test. Sorry. I need to change it into load. Yeah. Now it got appended. Go back again, open it. Okay, I can see customers. There are 0 customer, 1 customer, 2 customer. The 0th customer is Michael. He have purchased this stuff. So it's storing in a very systematic way. So it is very easy to process by a Python environment, including AI, right? So these are the name, Michael. She has purchased this one, and 2, these are the stuff. So now we have both these things, right? Johnson, Jennifer, and everything. So now we have appended the new customers into the JSON file. Okay. So now what I want to do is, I need to load the file and read it. So let's now the same thing. I'm opening the file in the read format, JSON load, and printing the option. The same code as that we have executed. Now you can see all these informations are gathered and printed over here. So now let's see, Michael is going to buy something new. That means what? I need to put that item into the JSON file as well. So how to do that, right? So to do that, here we are going to use for, where we have learned for last lectures. For is to iterate through lists, tuples, and dictionaries, right? So now we have kind of a dictionary format where we have to go through and search the name. I'm going to say for customer in data, customers, this is the customers. So right now, who are the customers that we have? We have Michael, who is the first guy, and we have Jennifer, and we have Johnson. These 3 people are there. So I'm going to add this item, airports 3rd generation, to the Michael, because Michael purchased that one. So how to do that? So I go to the thing for customer in data customers. Customers is the name. So what the for loop does, it goes one by one and check whether the name is there, right? Until it finds the name. So for customers, if customer name is equal to Michael, right? Customer purchases, I'm going to append airport third generation break. Break means once it done, it will come out of the loop, right? So this is all. So I'm going to search for the name first. If the name is found, then I'm going to append the third generation airport. Then I'm going to exit. That's all. So once this is defined with open, I'm going to type this logi.json w and data dump, shift enter. So by executing this code, I have successfully appended this Michael information airport third generation, right? So it's very easy. So this is easy, but in text file it's very hard. You have to go iterate and you have to find the name. It's not easy. Here it's very easy because it's step by step we have divided all these stuff. So that's why the JSON is very popular, right? Okay, cool. So now we'll go back again. So now I have done this one. So then load the file. We can read it over here also. Logi.json, put in the data. So now you can see the Michael has added this airport third generation, right? So I didn't put the file over here how to delete certain things. If he add to cart, then he remove. It's also possible. At the before the checkout, you see, oh my god, my budget is 2,000, now it's 2,500. I need to remove one item. Remove item. So then it need to get deleted from the JSON file. So I'm not going to help you to do that. Ask our AI teaching assistant. She will tell you how to remove the thing from JSON file as in home. Okay. So that you can try. Again, I'm going to say when you want to try new codes plus this one, if you add this one, you can enter code over here. Coding window, just click here, add this one. If you want to add something on top, add this one. So then you can type and you can execute the program and try it out in the program itself. You don't want to install any extra stuff. Now the JSON file, but we have learned how to create a JSON file, how to write or dump the data into the JSON file, how to read the JSON file, and how to append new information. So the writing the new information, it's in a structured way. We can very easily point out here only you need to go and write, right? See, for the customers in the data, that's a big customers. If you open up this JSON file, you will understand. So this is customers in the data, right? For customers in the data. So that's the code. If for customer mean what? It's going to go one by one. One by one. That's the for loop category, right? One by one. So we have 3 customers now. So it goes to first customer and check. If the customer name is Michael, then it add airports. So now let's say we will add something to Jennifer, right? I'm going to add something Jennifer. She bought something. So I'm going to add here Jennifer. If the name is Jennifer, then put airports third generation, right? So earlier Michael, now Jennifer is going to buy that. So once it's done, yeah. We write as a file, maybe customer, yeah, it's under this one. Yeah, it's appended as a first one, so it should be the Jennifer one. Okay, so this is 0, name Michael, name Jennifer. There is some issue. Let me clarify here. Yeah. Customers, Jennifer, Michael, maybe. Yeah. So now the Michael is working, the Jennifer has an issue. So let's figure out that one. Maybe you can ask to the chatbot, or else I will come back and do that thing again. Okay, so if you want to add another thing to the Michael, you can add Samsung charger. Okay, then append it's get appended over there. Okay, you can go ahead and see those stuff. Close it and open. Yes. 0 purchases 6 items, so you can see all these things are added. Right, so now the JSON file is done. This is also kind of storing the text information or any information. But when it's come to AI program, the AI in the first class we have learned, it's going to work with numbers, right? It's going to work with numbers. Even if we put some text, it convert that text into a number. So mostly what we use to save the numbers, Excel file, right? So all these data that we are going to put it into the Excel file. For training purpose, we are going to load that Excel file and we are going to run it. Okay. So next one is .csv file, handling the Excel file. So .csv, both are the same format, kind of. So we are going to learn how to handle the CSV file. For example, the weather forecasting, right? So we have learned today is going to rain, tomorrow is going to be raining continuously, or day after tomorrow is going to be fully sunny and cloudy. So these kind of stuffs are forecasted data. So how they forecast? So based on the previous history. So what is the previous history that they take? Date, time, temperature, date, time, temperature. So these are put into the column formats, right? Date, time, temperature. So based on the previous data, they load it and they train the AI model to forecast the rest. So most of the time, we are going to work in .csv file format when it's come to forecasting problems, because all are numbers, date, time, and temperature value, humidity value, all this stuff. Then you can forecast. So that is one example that we use all these CSV file or .excel file. CSV file is like the same format. If you open the Excel file, you can store it as .csv. When you store it as CSV, it's in the same format as looks like this. So you can go here, CSV. You can see here something called .csv, comma, delimited file, right? So in the Excel also we have that option. So in Python, we use that thing to store data or retrieve the data for training for the AI purposes. So to do that, first step what we need to do, to handle the CSV files in Python, we need to import the library which can handle the CSV file as we have done for the JSON, right? So I am going to import this CSV library into the Python environment. Same thing, I'm going to create a CSV file called logi.csv.w, shift, enter. So now I have created the CSV file in the format of logi. See here, I have created. You can open it up and see. So it's just a blank file, nothing is over there, right? So now what I'm going to do, I have created the file logi.csv is created. The second what we are going to do, we are going to create the date, time, and temperature for the forecasting purpose, let's say, right? So I'm going to save this information. To save this information, I need to create what are the information that we need for an Excel file. I need the column title and the data that I'm going to put into those columns, right? The same structure that I'm going to create. Column names are going to be, the first column name is data, second column name is time, third column name is temperature. Then after that, the data, this is the way that we have to create. If you see the date, 28/2023, time is 0. So this is 24-hour time. Let's say 0 means 12 a.m., 1, 2, 3 up to 23. Every hour the data was taken. So temperature is 22 degrees Celsius and data is here 22. Like that, we have created this thing, right? So this is the data I'm going to write into the created CSV file for one day, the same date. If you see the same day, one day, the temperature data, right? So now I'm going to create the logi here, W, and this new line should be added over here in this command. Earlier we didn't use this because this new line, every time the data is appended, it's need to go to the new line. If this is not there, then it will overwrite the same thing, right? So one line will be there, it will overwrite the same thing. So now for the CSV library, we have to say dict writer. For the text, we just use the write. For the JSON, we use the dump. For the CSV, we are going to use CSV dot dict writer file, and file names is equal to the column names. For row in data, write row. So these are the things, the data, and these are the rows that we are going to write, right? Simple, click shift enter. So now all these data are written to the CSV file. So you can go here and see, right? So 1, 2, 3, all these data are written over here. Okay. All right. So now go back again. Right. So this is enough. So you can try this one over here. Update a specific temperature to a certain data time. You can run it and you can check that over here. And how to delete data, how to add data, you can get the help from our AI teaching assistant. You can run it and execute. So now we have learned about dot text file and dot JSON file and dot CSV file. Where the text files are used mostly, text to speech conversion, and the chatbots especially, right? The chatbots ask here to our voice, change the speech into text, convert it into a text file, put it to the API and get back and do those stuff, right? The second thing is JSON file, most common file format that we have done, used in the Python for any purposes, right? So storing text file and most of the information. And the CSV file, when it's come to AI forecasting, many other applications when we are working with multiple numbers. For recently, we have done a project in Dubai to forecast the occupancy next day or next month in this date, what will be the occupancy in this hotel. So we have done a program, right? Forecasting occupancy in a hotel. And another program that we have done, forecasting revenue and item-wise sale. So all these things, what they have provided us is a CSV file. Basically, Excel file we have saved as a CSV file, and we have trained our AI model using that CSV file. Because when it's come to hotel entering, they don't know JSON file and everything, like very basic technical managers are going to use. So when they come, a new person come, then they enter these information into the front end. It will save the detail into the CSV file. So what they gave us is a CSV file. So in that CSV file we had date, time, number of guests, check values, total purchase, everything, all the detail, right? So from this thing we have forecasted how much items will be sold next month, this date it can forecast, right? So when it's come to forecasting, AI does not say this is the value that you will sell, right? It will say this might 90%, this might be the value you might get, right? That is a percentage value, right? When it's come to AI. So that's one project that we have done, and many other load forecasting when it's come to electrical engineering application, weather forecasting, load forecasting, demand forecasting. All these things are done in AI or any statistical way. They use the CSV format, right? The CSV format is going to be used heavily when it's come to AI application for forecasting and many other applications. Okay. So now we will go back again. We are going to go into another important libraries that we are going to use in AI programming, Matplotlib and Pandas. second. Okay, so let's now create a test CSV file, right? So give me a second. Is it there? The CSV file? Not yeah, maybe. Okay, that's fine. We have created the .csv. Okay, fine. So now what we will do is we will because when it's come to AI applications, right, we need to showcase certain parameters, right? So as I showed the line curve fitting stuff in the first day of the class, so that is the graph, right? Which the curve is moving up to fit the line, right? If we want to do the loss curve, for example, let me take this out and show certain information. Yeah, let's come back. So when we are working with Python program, we need to visualize certain stuff, right? That can be AI or cannot be AI, because to make decisions, we need to see that information, not in the CSV file. We have to plot and see how this data looks like. For the forecasting, it goes like this, and we need to see how the pattern looks like, right? So for the traders, if you see, they always visualize the pattern, not the numbers, right? So look at the pattern and they decide to sell the stock or purchase stock, right? The traders. So to visualizing this, we need to have certain libraries. So when we are working with the Python environment, we need to check how this plot is going to look like, right? Then we need to write a code and we have to plot it down. So to do that, what we use is matplot library, right? Matplot library. So this is a library that is already installed into the Python environment. We are going to import it, right? So when it's come to matplot library, that is a huge library, right? You can say it has many other components. But in this, we are going to call only the pyplot. It's a small library inside the big giant, maybe big basket and small boxes, right? So in this class, we are going to load big basket matplot, and we are not going to load the whole big basket. We're only going to take that small box and put it into the Python environment. So for that, we need to take this import matplotlib.pyplot as PLT. This PLT is a nickname that we are going to give for this library, right? It's a nickname. So always you can't say matplotlib.pyplot. It's going to take time for coding it. So this is a nickname for this library that we are going to use in this environment. Pandas. Pandas is a different stuff, kind of how to say, which is used to work with .csv file data form, right? If you just, without the pandas, if you use, it's just going to read it as, do you remember this CSV file read? It will print it in a row continuously. The JSON file that we have printed, it just printed in a row. When you go back to the JSON file and look at it, it's in a structured format. When you print it out over here, it's a continuous brackets and comma. So this PD is going to help us to structure the data format, right? So now don't confuse too much. This library is going to help us to plot certain stuff, and this library is going to help us to determine certain, like structure the data format. So now we have created the data file over here, which is logi CSV file, right? So I'm going to change this one to logi, and I'm going to enter. Okay, first I need to run this one, because see, now it's a data PD read CSV is not defined. Why? Because I didn't run this one. Now I'm loading the environment. You can see this is executing still. There's a star mark, right? It's not completed yet, right? It's still executing. Why? Because this matplot library is a huge library. So we are importing that matplot library to our environment. So it might take a certain time, right? Once it imported, and the PD also a little larger library, now it's ran, right? It took earlier, all the libraries, when you click enter on the real-time more or less, it's loaded. Now The matplot library is a huge library. Inside that, we need to load a small one, a small bucket, and we are putting into this environment. And we are giving this guy a name called PLT. It's a nickname. We are going to use that. Similarly, we are importing the pandas, and this PD is a nickname. This PD is a nickname that we have given to these pandas. So these are very common nicknames. So we can change this nickname as well as you wish. But these are very commonly used nicknames. So when you write code, it's always better to use the common nickname. Then others can understand what you are trying to do. Otherwise, if you use, instead of PLT, use PTL and everything, others won't understand. And certain program helpers are there, right? For example, automatic error handling issues. So those errors will not detect if you change the nickname. It will say maybe it's an error. So it's always better use these common names. So we are going to use PLT for the plot, PD for the pandas. So now if you see, I'm using this PD over here, PD dot. So that means I am reading using the pandas library, pd.read CSV login. So now I read the data from the CV and I'm going to print the data. Now you can see all these informations are loaded from the CSV file, right? All the detail are loaded from the CSV file that we have stored. So this is, if you, without the PD, if you just load the CSV file, it won't give you in this structured format. It will give you like a continuous line, right? So that's why the PD is very important. So now let's say we are going to visualize this data in a different form. This time in the form of a scatter plot of a data with time in horizontal axis and the temperature in the vertical axis. So we can visualize the data in different ways: line plot, scatter plot, bar chart, anyways, right? So now first we will do the scatter plot figure. So this is the data. So we need the time and the temperature. Date is the same. So we will go to the time and the temperature, right? So now I'm going to plot the figure here, right? Give me a second. There's a small code error. Okay. So now what will happen while we are creating the data, so it put the heading as this, right? So I did a mistake while creating the data. So I should have put the title as data, time, temperature. So while creating, I made a mistake. So now this is going to take as a title of the column. So for now, we will use that. But when you are writing in home, just you can change it into temperature when you are appending the data. Okay. So now the column title is 0 and this column title is 22. So now we have to change that over here, 0 and 22. So to plot the thing, here I am calling PLT. Where is this PLT? I gave the nickname to this guy, matplot library pyplot, as PLT, right? This is the nickname that I gave to this guy, right? So I'm going to use that person, PLT here, and figure the size of the figure, 8, 6. You can change 6 by 6 also. That's totally fine. So we can change the figure size here and we can print it. It will change the figure size. If you want the figure size to be changed, 8 by 6, this is 8 by 6, right? So 10 by 6, we can change. You can see this with this getting higher, right? So that we will stick to the 8 by 6 because it fits the window very nicely. Yeah. Then I'm going to say plot. The first thing I'm going to plot the scatter plot. So to get the scatter plot means what? Dot, 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 dot to the according to the point. So now I'm going to call the PLT, the nickname that I have given, dot scatter. It's a scatter plot from data 0, that is the x-axis, from the data 22, that is the y-axis. If you go here, data 0, this is the time, and this is the temperature, right? So now I'm going to get the time and temperature again, saying just mistakenly created this with this column title. Otherwise, this column title should be added over here, time and temperature. So once plot show, you can see now 0, 5, 10, 15, 20, up to 23, all these temperature points are shown over here as a scatter plot, right? So engineers always like to see these things, even statistical analysis. Every people would like to see a graph to make decision, not the points, number points, right? So this is easier way. And in AI programming also, we have seen the loss curve in the first example. Every time iteration goes, the loss goes down and everything. All are using this example. Okay, matplot library. So now what we'll do is, so this figure is little incomplete. Why? If we see the figure, we should have an XY label also, right? We need to have XY label. We have to have points. Can you just guess what is the point for 6? It's not here. You just randomly go here and see, okay, this might be the point for 6. So this is an incomplete graph. So we need to add the figure title and everything, right? So this is going to be 0 again. This is going to be 20. Change this one. Okay. So because the column name is the thing. So now I am going to plot the figure 18 to 6, same thing. Plot it in a scatter plot format. And I am going to add a X label, that is time in hours. And I'm going to add the Y label, temperature in Celsius. If you see, all the time I am calling PLT, PLT, PLT. If I don't give that nickname, I need to always say matplot.pyplot, matplot light plot west of time while coding. So that's why this PLT dot thing is used in this program. So if you want to use pandas, rather than go and type is pandas.read, pandas.read, pd.read, faster, right? So now this plot Y label, I'm adding the Y label here, the Celsius. Then the graph should have a title. So the title, PLT title, nothing else. If you see X label, PLT.Y label, PLT.title, time versus temperature, right? Then I'm going to add the grid lines because I cannot see which point belongs to which thing. So I'm going to plot grid, PLT grid, and I'm going to show how it's going to look like. When you print it, you can see the new graph, which has a time in hours, temperature in Celsius, XY labels are added, and time versus temperature, and the grid points also added, right? So now this seems to be a really good visualization of a complete graph. But still, I cannot see the trend, right? I cannot see the trend. These are dots. So I would like to see how these dots are connected. When it's connected, how it looks like. So to do that, I'm going to use the line graph, right? For that, I'm going to read that name 0 and here 22. Sorry about that. And here also 0 and here also 22. First change that. So now what is going to happen is, okay, so I'm going to plot the figure in 8:6 size. So these are the data that I'm going to plot in the scatter plot. Then what I'm going to do now is I'm going to connect all the dots through a red line, right? To see how these trend varies through the red line. To do that, I'm going to use PLT, that's the nickname, dot plot, right? Data 0, 22, color I'm defining as red. You can change the color to blue, green, anything, just in the word that you, real color word like BLUE, YELLOW, whatever. So it will take it. So then the other thing, time versus temperature is the heading. The same Y label, X label I am adding, and grid I am turning it on and plot the show. Now you can see the red line is connected over here, right? So all the dots are connected. So here you can see the green, you can get the green line, right? So now it's like a completely plotted graph you are looking at it. So now I'm going to plot a bar chart. right? I'm going to plot a bar chart. Here I'm going to change this again to 0, and this should go to 22 again. Sorry about that. Then the bar chart is going to be orange color, right? So I'm plotting figure. This is the figure size. To plot the scatter plot, I use plot dot scatter. To put the red line or green line on top of that, I put this plt dot plot. To put the bar chart, nothing rocket science, plt dot bar. Simple, nothing else. Instead of scatter, I'm going to change the bar. And all the other title, X label, Y label are the same. Then I'm going to print it. You can see the bar chart, time versus this thing. And here you can change it into green or blue, whatever the color, it's going to get displayed. Okay, so this is another way. And in certain places, you used to get the histogram. Do you know what it mean by histogram? Histogram means how many times the 22 degrees Celsius occurred, how many times 23 degrees Celsius occurred in a day. So how many times this occurred? So that is the histogram plot. So to plot that one, we just go here, plot figure, define the figure size. Again, nothing changed. Instead of scatter, plot, and other thing, we just put the hist, and it's going to get the histogram automatically. 0. Okay. That is temperature, right? Date temperature. So it should be 22. Right? Temperature column is this. For our temperature column is now labeled as mistakenly 22. So that is the histogram plot. So how many times this temperature occurs, I'm going to check. So I define the label, temperature distribution histogram, title, X label, X-axis label temperature in degrees Celsius, Y-axis label frequency, and I plot it. You can see the 22 degrees Celsius happened 2 times, and 23 degrees Celsius happened 3 times in a day, 24 degrees Celsius happened 3 times. So like that, you will get the histogram graph. So these are very basic stuff to visualize the content. So for example, for these hostel dashboard, I will show you maybe at the end of the thing, where they forecast and they see these graphs, the forecasted graph, and they don't want the exact point. So how much is the revenue tomorrow? They don't want. They want to know whether revenue is going to go high from today or low from today. So then to do that, they don't want to go and check the numbers. They would like to see the trend of these forecasted values. So to show that forecasted value, we have used matplot library Pyplot, okay, as a PLT option in the Python. So these are to showcase all these things. You will use these things while using the training, because there is an issue, overfitting. Overfitting is another interesting thing when it's come to AI. Imagine you are teaching a kid, right? You only show Apple image to the kid. This is Apple, this is Apple, this is only you are teaching Apple. Only you are teaching Apple, right? The kid brain is now tuned to know only Apple. When you go to a supermarket, there is a peach in the show place. The kid will identify that as an apple, because this kid learns only Apple. That is called kind of overfitting, right? You are putting too much of data. This is this, this is this, this is this, like that. Then rather than trying to identify the features, the AI try to learn, okay, this means this. That means it's not going to learn. It's going to be overfitted. Like the way that I said, the kid is going to detect the apple as peach as apple again, because the brain neurons overfitted, right? So we can't do it to AI. It's going to do a force value prediction or force value forecasting. So to see whether it's overfitting or not, we need to see the training loss curve and the validation loss curve, right? We will see that in the 5th week. To see those stuff, we need to plot it and see, right? To plot that, we are going to use this library. All right? Okay, cool. So now this is done. So then images. So when it's come to images, Tesla's self-driving car, right? So it takes the decision based on the images, right? Based on the images taken. While going, they take the image, see the objects, take the image every milliseconds, couple of milliseconds, and it get those images and analyze, then the AI decide to stop or the car is going or whatever going inside. So there is an interesting example in the YouTube, you can go and see. The Tesla car is detecting the horse cart. It's going on a highway. On a highway, the horse cart is going in front of the Tesla car. The Tesla car is detecting the horse cart as a car first, then as a lorry, then as, because it was not trained on the horse cart. Who will go in a horse cart in a highway? But unfortunately, it encountered a horse cart. AI model doesn't know that is a horse cart because it was not trained. It tried to match the horse cart feature first to the lorry, then to the bus, then to the container, and it confuses. It's in YouTube. Just go and type Tesla car confuses with horse cart, right? You can visualize this because that is not trained on that model. So it doesn't know it's a horse cart, right? If you don't tell a kid this is what this is, where the kid get the information from? Nowhere, right? So it tried to match with the information that it knows car, then it get confuses. So that's a one funny video. So now again, when we are working with the images, right, we should see these images, right? Whether this image is good or bad, this is the right image that we are going to use for the AI training, or this is the wrong image. All these things we have to see from the visualization, because when it's come to AI training, we are going to use thousands and millions of images, right? It's not 10, 5 images. So you want to randomly pick an image from 10,000 images and see how the image looks like. You just go and open the folder and go by that thing. It's not easy. So you use the Python, code it, get the image and visualize it in the Python environment itself. For that, we are going to use the matplot library again. So here we are going to use two libraries. One is import matplot library pyplot. This is that we have used just before as a PLT. I gave the nickname. Then the second small basket that I'm going to work with image, right? Earlier I just only worked with the plot. So I'm going to work with the image now. So I'm going to import the big library, matplot library dot image, right? This is a small basket out of the big basket. And I'm giving an image nickname as MPIMG. MP, matplot, IMG image, right? So that's the thing. So now let's load the image and see. Here we will have certain images, maybe. Let me see. Car, right? There's a car JPG. Let's take the car, right? So instead of image, I'm going to say car. C is capital because we have to label it in the one, or you can say image 1, image 2, it doesn't matter. We'll take the image 1 also. Here, there's an image 1 in the already stored one, image 1. So let's see what is that image 1. It's very simple, nothing else you do. You just go here, load the image1.jpg, image, MPIMG, that is the nickname, as we have used for the PLT scatter, PLT plot, PLT hist. I'm going to use MPIMG, IM read, image read, IM read, the image name. So now, why it's giving an error? Because I didn't execute this cell. I need to load it. Right. Let's load and sit because it's going to take a while, because it's a huge MATLAB library and we are, it was fast maybe. Okay, good. So yeah, why? Because we already have loaded the pyplot in the previous example to the Python environment. Now only it's loaded the image to that thing. It was faster than the previous one. Good. So now if you printed it out, so now I have loaded the image into the Python environment, right? Then I need to show the image. So I'm going to use plot image show, the same command that I have used for the scatter plot image show. Plot title image of the car. So maybe, yeah, whatever. See, image of a car. So that's the image of a car. I have loaded it over here. Then I am showing it. Yeah. Yeah, because I have stored this image file over here. Yeah, right. So now it's loaded thing. So the name, the name image 1. So if I want to load something image 2, you can put here image 2 and image of something, then this is the image 2. You get it? Yeah. So now this is image 1. So we'll image 1 and this one. All right. So image of a car. So now if I want to plot multiple images in an array, so there are 1, 2, 3, 4 images. I want to see all the 4 images in one block, right? That happens usually when it's come to these AI detection exam, right? So we'll go through that. So now I'm going to 2 by 2 subplots, 1, 2, 3, 4. I'm going to visualize 4 images at the same time. First one, image 1, image of a car. Second one, image 2, image of pedestrians. Image 3, image of a van. Image 4, image of a motorcycle, right? So then I'm going to put that. You can see all this stuff. Image of a car, image of pedestrian, image of a van, image of a motorbike, right? So all these things are loaded, title is added, and these things are visualized as a grid. To do that, first I created the grid 2 by 2, right? And I defined where this image should go. The image 1 should go in 0, 0. 0, 0 means this place. This is 0, 0. This is 0, 1. This is 1, 0. This is 1, 1. The matrix way, right? The same matrix way. 0, 0 position, 0, 1 position, 1, 0 position, 1, 1 position. So I label it here. The first car should go to 0, 0 position, and the image 2, image of a pedestrian, goes to 0, 1 position, and the image 3 goes to 1, 0 position, and image 4 goes to 1, 1 position. So once I positioned it, I do it. For example, I'm going to say put this 0, 0. I'm going to convert the motorbike and car into same different places. So you can get that thing over here. Then here I'm going to put 1, 1. Yeah. So now you see the motorbike and cars are interchanged just by changing the label. So now I created that grid and I created that thing. So now that is all about the matplot library, how to show, how to visualize the plot, how to do that. So now we are going to go to the another lesson is NumPy, right? So that is the other one called NumPy. If you would like to take a 5 minutes break, you can go and take, then come back, or else we can continue if you wish. Would like to have a break? 10 minutes maybe? Okay, right? Yeah, we'll take a break and come, right? Okay. Now 11:20 we'll start. Another 15 minutes we'll be able to come. So this NumPy is a very, very important thing. So we have to be focused, right? Yeah. We'll take a break and come back. Yeah, and you use this AI tool as much as possible if you want. Then you can clarify the doubts and you can do the stuff. Right? Counted when we are going to learn AI, right? Okay. All right. Now we will come to the NumPy. NumPy is the important thing. Since you know the AI in the first lecture, if nobody have watched that video, please go and watch it that the first week. AI is nothing but multiplication of numbers, right? You multiply it with the weights, with the inputs, weights with the inputs, and provide the output. It's a multiplication of numbers, right? When it's come to single neuron, it's easy. When it come to 10 neurons, 4 neurons, it took some time, right? For us in the example. But in AI network, we are not going to use 1 or 2 most of the time. So the built-up classification network itself have 1224 layers in one, 512 another, and 214, 64, 32. So 6 layers of this much of neurons interconnected for that example that I have shown, the classification example, hospitality venue or not hospitality venue, that have 6 layers with 1224 divided by 2, like that, right? So you can imagine how many multiplication that we are going to do to take the output. So In CPU, we have 4 cores, my computer. But when it's come to GPU, based on the GPU capacity, it has 3,856 cores. So that means all these multiplication, 3,000, this amount of multiplication can happen at the same time. So if you want to do multiple multiplication at the same time, what is the easiest way? Is matrix multiplication, right? You put this information into a matrix, do the multiplication, it will be faster rather than going and one by one, one by one, one by one. So the matrix multiplication is going to be very important when it's come to AI to make the decision for whatever the AI model that we are going to use in the future. This is going to be a important library. In all the information, we are going to use NumPy as NP, right? NP is a nickname that I'm giving to this NumPy guy. NumPy as NP. You can change this nickname as you wish, but it's not recommended because others, when they are looking at the code, they won't understand. Even the error detection mechanism implemented into the code detectors will not understand because that is given by this NP name. Okay, all right. So now if you see, this is a matrix. You know matrix, right? 8, 4, 3, that these are the matrix. So now let's say I'm going to create a matrix. So to create the matrix, 8, 4, 3, minus 5, 6, minus 2, 7, 9, minus 8. So if you see 8, 4, 2, this is a row and these are columns. So when we create a matrix, we create row by row, right? To create a row, we say matrix is equal to np.array. Inside this bracket, 8, 4, 3, right? If you go back and see 8, 4, 3, one row. And I closes that square bracket. And comma means I'm coming to the next row. Minus 5, 6, minus 2. Minus 5, 6, minus 2. I closes the square bracket, comma, next to the row, 7, 9, minus 8, done. Then I'm going to print the matrix, right? If to create that 3 by 3 matrix, 3 by 3 means 3 elements in the row, 3 elements in the column, right? So I just execute it, np.array. That is the command to create a matrix. So I created a matrix in this form, right? So the same matrix. Now let's add these two matrices, right? 8, 4, 3, minus 5, 6, minus 2, this matrix plus this matrix. How the matrix addition happens? The same row element and the same element over here add together. 8 plus 1. 4 minus 2. 4 plus minus 2. 3 plus 5. Right? Then come to the second row. Minus 5 plus 2. 6 plus minus 7. Like that, the element wise it's going to get added. Right? So then the final answer should be this one. So if you want to manually do it, it takes time. So what you do? Go, first I'm going to create a matrix. The matrix name is 1. Matrix 1. That is 8, 4, 3, minus 5, 6, minus 2, this matrix, right? I'm going to create this matrix, the first one. Then, then second matrix, that is going to be this one, 1 minus 2, 5, 2 minus 7, 2, 2 minus 5, 3. So I'm creating it 1 minus 2, 5, 2 minus the same way. Then the result, simple, we know how to add the thing. We learned arithmetic operators last week. So just use the plus symbol, matrix 1 and matrix 2, and print matrix addition results. This is a title. When you are putting it into a double inverted column, it counted as a title, right? Then the print the result. So now if you print it out, you will see matrix addition results is done 928 minus 3 minus 1 0 9 4 minus 5, the same, right? So now I'm going to do the matrix multiplication. So when it's come to matrix multiplication, there are two types of matrix multiplication. One is element wise matrix multiplication, other one is column and row, right? So if you put this type of thing, so this is element wise matrix multiplication. One multiplication means this 8 is going to be multiplied by 1, 4 is going to be multiplied by minus 2, 3 is going to be multiplied by minus 5. This minus 8 is going to multiply by 3. So it's a element wise, right? This is element wise addition. This is element wise multiplication. So I already have defined the matrix here, matrix 1, matrix 2. Now the MATLAB knows what is this matrix 1 and matrix 2. So what it's going to do is, it's going to multiply and show the value, element wise value over here. Okay, all right. So now if I use this one, division, element wise division means 8 divided by 1, 4 divided by minus 2, 3 divided by 5. So these are called element wise division. To do that, we use NP divide command, not the /1, right? Addition, multiplication, the same thing that we have used over here, element wise. For the element wise division, we use NP is the card name that I have given to this guy, nickname, dot divide matrix 1, matrix 2. The matrix 1, whichever you put in the front is going to come on the top. The second one is going to be the denominator, right? So now you print the results. Now you can see 8 divided by 1, 4 divided by minus 2, that is minus 2, and 3 divided by 5, that is there. All the decisions are printed out. So now, what if I'm going to, there's a big matrix, let's say a large matrix. I want to see what is the value at a certain point. So then I need to go and see the matrix, and you can see it, go in there. So I need to just go and say, okay, what is the value at the 0 column, first row, something like that, right? So in this case, if you see this one, 8, 4, 3, minus 5, 6, minus 2, 7 in this matrix, right? In this matrix. So I'm going to print 0, 1. 0 row, first column. That means this is the 0 row, 8, 4, 3 is the 0 row. First column means what? This is 0th column in MATLAB, say Python, right? 0 column, first column, second column. 0 row, first row, second row. So I'm going to print the 0 row, first column means 0 column, first column. That should be number 4, right? So now I go there and I say print matrix 0, 1, right? So that means element row 0, column 1, it should print number 4. You can change what is that for 2, it should give 3, right? If you want to see 1, 2, that should give minus 2, right? So you can change and you can get the certain elements from there itself. Clear? So now this is matrix multiplication is easy. But other thing where we are going to use this matrix is, we are going to convert image recognition that I have showed you, hospitality venue or not hospitality venue. How we have detected is, first we need to convert the image into numbers, right? Because AI only can work with numbers. So when you want to convert into numbers, the way we convert is image into pixels. So now this is an image number 8, right? So now when you convert it into pixels, this is the pixel values. So 0 means pitch dark value, 255 means maximum white. So this is a gray and black image, grayscale image, right? Black and white. RGB means red, green, blue. It's a color image. So we'll come to that later. So now we will work with the black image. So now 0 means pitch dark. White means, pure white means 255. You can see all these numbers. 0 is here, is dark. Somewhere around here, it's pure white. So 255 is here. So that's how these colors are ranked. So based on this pitch dark to white, they have divided the colors into 250 scales. So now they give the colors each number. Now we have the number matrix, not the image. We converted the image into pixel matrix, right? So now we can play with these as we wish, right? For example, right, there is a car image. right? I'm going to load the car image and I'm going to play with the pixels. For that, I need the import matplotlib plot library, import matplotlib image as an MP. These two are the things that I want because I'm going to play with the plot and I'm going to play with an image. Image, MPING, image read car. So I load the car image into the environment. So I already have the car image here, car JPG stored over here. If you do want to play with some other thing from your computer, drag and drop that car image over here, it will be stored automatically. So you go to your folder, drag and drop it over here, it will store, then you can call that image as well when you want to play with other images. Okay, so now I have done it. And plot image show, so I'm going to see the gray color car, image of a car, right? Then I'm going to see image of a car. That car image is shown over here, right? Image of a car, title, XY label are printed. So now I need to know what is the height and width of this image. For that, I am going to say image height, comma image width is equal to image dot shape. Dot shape is a command which is embedded in this library, right? So then it's going to take that thing. Then I'm going to print that thing in the pixels, not in this thing. So it has 167 pixels height and 250 pixels width. 100 and you can see 67 here, 0 to 160, 67 somewhere over here, 0 to 200 and maybe 250 somewhere here. Yeah, 250 pixels, right, of this image. So now what we will do is we will extract the pixel value of this gray image, right? Easy to work with gray image because we are using Jupyter Notebook, which is running on your browser. If you load the browser, it will stuck, right? Next class, we are going to load the browser a little bit to do a training, AI training. But this class, we will use this one, okay? This gray. So now, matrix image matrix np.array image. This is the one. So to create a matrix, the same thing that we have used, and we created the matrix. To create the matrix out of this image, because this image is defined over here, image is equal to MPING image read card. So that means this image is loaded already in the name of image in the Python. So I am calling it over here nb.array image, and I'm going to print the image matrix now. Let's print it. Why is short? It should be 120, 67 by 250, right? Actually, it's 167 by 250. You can see the dot, 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 dot. So that means a big pixel. It cannot see all the pixel values into this Python environment. So it's showing in a shorter form, right? So now, in many traffic applications in US, they capture an image through a camera, then they get this down number plates, right? And they track if he is doing a number plate violation or traffic violation, then the ticket comes to house, right? So now the issue is, now we have AI, advanced AI model, which look at the car, it can detect the nameplate completely without any issues. That's the application that I have used to detect the nameplate boards in that example that I have showed you, the real example, right? So, but earlier days, it's not the case. So we take an image, we have to specify where the number plate it is. Early days, not now. Modern AI, this early AI, right? So now I'm going to cut this part because the number plate is the important thing. I don't care what car is, right? The number plate is the important thing for me. So now if you roughly see, this is around 110 to 140 in this way, and 162 somewhere around 220, right? So I'm going to cut this part. How to do that? So I'm going to say, I'm going to create a sub matrix, right? Because now this is the matrix, complete matrix of the car. This is a sub matrix I'm going to pull out from the car, right? So this is a sub matrix which is equal to 110 to 140 and 160 to 220, right? So that means I'm going to get the pixel values in these areas because I'm going to get the number plate on. So I created a matrix which is submatrix, the same way image matrix, this one, and the print the submatrix. Now you can see this is the matrix printed, which is extracted from these areas, right? From these areas. Again, there are some dots over here because it's a large matrix to visualize. So now I have sliced the matrix, right? Slice the matrix. Now plot and see. So now when you plot the sliced matrix, you can get the nameplate only, right? So these kind of applications are going to be used in AI for image and object detection. So we have to go and specify this is the area. Let's say I have done an example, smart traffic monitoring system. Because in US, when the ambulance comes, right, all the signal lights become, in a four-way junction, all the signal lights become red, ambulance can pass by, and there is a flashlight goes on, right? So how they do the detection is through an image classification and the sound detection, right? Both the thing integrated together, they do. So in Morocco, I have conducted a research image smart traffic monitoring system. So it identifies the ambulance. To do that, on a road, we have to specify where the ambulance is, right? We took thousands of images. We went and rectified. This is the ambulance pixel. This is the ambulance pixels, right? One by one, we crop the ambulance area. Then we train them on. So similarly, here you have done this sliced image of a number plate. Now the traffic application is easy, right? So that is the one part. And the second part is flattening. So this is one part we will use in the fifth lecture, flattening. Flattening means putting into this way. Why we need it? This is a matrix. And why we need to 843 minus 56 minus 279 minus 8? Why we need it? How the neurons looks like? Does it looks like a matrix? It's one column, right? So whatever the matrix you have to convert it into one column and feed all the numbers, right? Right. So to do that, we need to do the flattening. How to do the flattening? This is the matrix. Nothing rocket science. So this is the matrix I have defined. Matrix dot flatten. This is the command that I'm going to use. Very straightforward. Flattened array. I'm going to say matrix dot flatten. Right? Original matrix 1 and the flattened array. I'm going to print it. You can see this is the original matrix and this is the flattened matrix. So now I can give it in one neuron, one by one neurons, put all the matrix to there. Even if you have 256 by 167, if you're going to work with this image, what is the input neuron size that you should have? It should be 160 by 250. Numbers of neurons you should have in the input layer to feed the image as an input, right? So now it's clear, right? It's a matrix. Neurons are in one layer, one column. So I need to convert that to one column and feed it. So that's why I do this flattening. To do that flattening, I use this dot flatten option over here, right? So now I flatten the matrix over here. So now there is a practice exercise. Load the car JPG image and slice the car logo region and plot it. So what you need to do, you go here, check the approximate car logo where it's located and call that matrix over here, chop it as a submatrix and print that submatrix back again. That's all, right? So you can do that at home. So now the NP is done. Then feature extraction. This is the one of the best for deep learning. So now we have converted into matrix, right? One way. So I said two ways of machine learning and deep learning, right? Two things are there. Machine learning is we extract the feature and we give it to the neural network, right? Deep learning, it extracts the feature by itself, right? It extracts the feature by itself. How it does? That is called as convolution. Convolution, right? So, for example, if I want to explain the convolution, now if I want to extract the feature out of an image, what feature I extract? Only the feature that I can extract is the pixel value, right? When you go with the pixel values, it is not much accurate. because in certain places you will get confused. The AI model will, if you see another image more or less close to the certain pixel values, it will misrecognize that is suitable for hospitality purpose, right? So in that case, we let the AI to decide what feature you want, you take it. I don't care. This is the image. You decide what feature you want to do, extract for your classification. So to do that, we use convolution, right? Again, it's a matrix operation. Convolution is a matrix operation. So this is a big matrix, right? So what we do when you put an image, big image. Now for the car image, again another problem is there. So you have to create the input neuron size up to 165 to 250, right? The number of neurons, that's a huge. So when it's come to computational power, it's going to take a long time. So then I don't want to convert that in that way. So I need to reduce the number of neurons also, right? So in that case, what I do a convolution that is going to help. So convolution means you can see a small dark blue is moving here and there, right? So that number 012, 220, 012, that is fixed, right? That is fixed. So now what this is called is as filter. It's a filter. So what it's going to go is, the filter value is a matrix again, 012, 220, 012. So this is the filter size. So this filter is going to move like this as it moves. While it moves, what is going to happen is, imagine this 3 is going to multiply by 0, and this 3 is going to be multiplied by 1. For example, if I can stop it, right? So 3 by 2, like that. So this all these, when this guy is over here in this area, 3 by 3 area, these elements are going to get multiplied by element wise. 3 is going to multiply by 0, 3 is going to multiply by 1, 2 is going to multiply by 2, 0 is going to, then the average of that thing is going to be loaded over here, right? Then from this point, this guy moved to second column. Then the second part, it takes multiply element wise multiplication, add all the thing, take the average, put it over here. Then the third column, multiply all the things and take the average over here. So like that, now I have 1, 2, 3, 4, 5 by 5 matrix, which is reduced to 3 by 3. Now if I flatten this, here I should have 25 neurons if I want to put the pixel value inside. Now I have only 3 by 3, 9 neurons. 25 to 9 I reduce, right? By doing this operation called convolution, right? This is going to be used in deep learning, right? Deep learning is this. So we not only use one deep convolutional neural network, get the another matrix, reduce matrix, and take that matrix, do the convolution, reduce it, count, finally come to 512 layers, 1024 layers. Then we feed that input to that thing. So during this multiple convolution neural network, the car image that you put in, what is the neural network is going to see is completely different, because you are multiplying something and getting something. But that is the feature that the neural network is going to take in to classify as a car, right? So that is convolution feature extraction. So how to do that? For that, we need the NumPy library also, image library, pyplot library. Let's all of them into the environment, right? Then we are going to plot the car and show the car, the same thing that we have done here, no code change. Then I'm going to get the matrix out of this car, right? I took the matrix out of this car, the same command that I have executed in the previous slide. Then I'm going to define the filter. This blue color, dark blue color is the guy called filter. In other words, we call it as kernel. We call it as kernels, right? Kernel, now this is the kernel 012, 220, 012. So the same kernel I have here 012, 220, 012, 012, 220, 012. I am defining this matrix as a kernel. So this is the kernel matrix I have created. Now what I am going to do is, I am going to move this matrix through that car image to extract the feature and see how the car image changes. Okay, only one convolutional, right? Convolution pathway. So now I created the kernel. What I'm going to do is I'm going to normalize the kernel. So the normalization is important when it's come to a application to suppress certain value into a certain range. So you have 0 to 1500. When you suppress 0 to 1, that is normalized, right? It's a large variance is there. When you normalize, all the variance come to a small range. So that is a common practice when it's come to when it comes to normalization. So normalizing the kernel to have a sum of 1 ensures then when it's used for convolution, this multiplication, the brightness remains consistent. So for that purpose, we need to do the normalization. To do the normalization, what we do? We know how to get the kernel total number, np.sum, kernel, that is the total. Total means what? It's going to get add up 0 plus 1 plus 2 plus 2 plus 2 plus 0, 0 plus 1 plus 2. That is the kernel addition divided by the individual kernel values. So once you print it, so now this is the normalized kernel, right? If you do the normalized kernel operation, the final output image brightness wouldn't get changed. Right? Now I have created the kernel. Now I extracted the pixel from the car image. I'm going to do the convolution operation. To do the convolution operation, what I need to do? I need to move this kernel one by one pixel until this car pixel is over. So if I want to do that, what we have learned to iterate through certain things, what I have learned just time, for loop. Right? We have used the for loop to iterate through dictionary, something. So here I'm going to use the for loop to iterate this kernel, move this kernel by pixel, getting the average and create a new matrix. So which is 4i in range 1, image shape 0 minus 1. So this is the second, this is for column and this is for row, and the convolution image is this one. So you don't want to go into detail, just this is a convolution operation, that is enough, right? So, but if you want to understand, you know the for loop, you can understand the code now, right? So let's perform the operation right now. So now this is the convoluted value of our new image, right? So now I took the pure matrix, I created the kernel filter, I created the convolution network, so convolution path. Now I am going to print the first original image and the convoluted matrix image. So now this is the convoluted matrix, right? So now this is the original matrix of the car. This is the original matrix of the car. This is the convoluted matrix of the car. So I'm going to plot the convoluted and the image. So you can see this is the original image and this is the convoluted image. This is sharper. This is little become blurred. How many of you have seen the blurred operation in blur your background in Zoom, Teams? You know how it happens now, right? It's simple matrix multiplication, detect you, rest of the things are blurred, right? So that is one example. And blurring, this is one feature. So by changing this thing, this kernel, you can change this kernel, you can completely change these values. You can make it sharper, you can make it blurred, you can make it as you wish, right? So all becomes on the kernel values. So now I define this kernel as random, like 0, 1, 2, 2, 2, 0, 1, 1, 1. So you can also change this to 0 and let's see how it varies. Okay, 0, right? I'm going to change it to 0 and this one also to 0 and this one also maybe 1. Okay, this is a different convolution image. Kernel, I'm going to prepare that kernel, running it again. So this is the prepared one, running it again. So now remember this image. Okay, remember this image. I changed the kernel. So now it's get changed. I got a kind of a dark color over here. Earlier the dark color was not there. So the new image generated, it might be little different. So now this is one kernel operation, right? So in the convolution neural network, deep learning, you have multiple kernels. So this image will go to the next, then kernel operation, then next kernel operation, next, like that you can keep on going. Okay, so that is the one. And the max pooling. So now kernel operation sometimes reduces the amount of the matrix size. Sometimes it gives the same matrix size also by filling the seat.
Dr. Logi, we cannot hear you. Dr. Logi, can you hear me? Dr. Logi. Dr. Logi, we cannot hear you.
Can you hear me now?
Yeah.
Any?
Yeah, now it's okay. Yeah.
Okay. So now if you see here, the mean intensity, nothing. NP is the card name dot mean. NP dot average. NP min. NP max. NP standard deviation. NP median. So all these things are predefined functions. Functions. Somewhere we have learned about these functions, right? Last class. So we define the functions and we call it here. So like that in the NP library, they have defined all these functions. So we just call them over here. NP mean means this image will be put in over here, extract the image, it calculate and return back. So once you run it, you can see here, mean intensity value is 75, average intensity is this much, minimum intensity is 1, maximum intensity is 214, standard deviation is this much, median intensity is this much. So like that, the NP NumPy library is kind of a heart for AI applications, right? So that's all for today's lecture. So did I say something? Yeah. Yeah, let me show some other example.